Hi guys, welcome back. We're going to do another lesson concerning systems of equations. The only difference that we're going to do today is that instead of learning by graphing, we're going to learn by substitution. So we're going to solve it using algebra rather than a graph. Okay? So let's go ahead and get started. So there are 4 steps, just like with graphing. I'm going to close that. 4 steps on how to solve a system by substitution. Okay? There we go. And again, if at any time I'm going too fast, pause the video, and then you can take your time. Oh, sorry, there's 5 steps. That's okay. Just pause the video, and you can go ahead and write it, and then push play when you're ready to move on. Alright, so step 1 is to set one of the equations equal to either of the variables. So you can set it either equal to x or to y. You guys have already been used to setting it to y to look like slope-intercept form, so that might be your preference. But if it's easier to get x by itself, go ahead and get x by itself then. Okay? Once you have that equation with a variable by itself, you're going to plug in the expression that that variable equals into that variable in the other equation, if that makes sense. So plug in the expression that is equal to your variable in for the same variable in the other equation. Don't plug it back into that equation you were just working off of. It doesn't help you. Okay? So, I just realized what that was. Oh, sorry. There's something moving on my screen. That's my background here. Then number 3, once we plug it back in, like plug that variable in for its expression, we'll only have one variable, and we just solve for that variable. So then we either have an x or a y then. If we have one of the variables, we can then go ahead and find the other one using step 4. We substitute in the found value of the variable that we had into one of the original equations, doesn't matter which one, and you solve for the variable that's left. Okay? So then you'll get the other half of your ordered pair. Step 5 is just to check your solution by substituting in your x and your y values into all the equations in the system to make sure you get true statements for everything. Okay? Let's go ahead and try. Alright, so we are going to do this problem. 3x minus y equals 4, and we have x equals 5 minus 2y. Okay, so we're doing substitution, right? So we need one variable by itself. In this problem, we are very lucky because we already have an x here by itself. Okay, so what we're going to do is take what x equals, the 5 minus 2y, we're going to take that 5 minus 2y and plug it in for this x in the other equation. Okay, so it's going to look like this. We have 3 times 5 minus 2y, and that 5 minus 2y is in parentheses, minus y equals 4. Then we go ahead and just simplify it. So we distribute out this 3, so we get 15 minus 6y minus y. Combine our like terms to get minus 7y. And then solve for y. So I subtract 15 from both sides. I get negative 11 over here. I get the negative 7y by itself. Divide everything by negative 7. I get an ugly number, but it's a number. I get y equals 11 over 7. Okay? Now that I have a y, I can take that value for y and plug it into either of these two y's in these equations. Okay? So let's go up here. Let's plug it in down in this one, because it's already here and we're solving for an x, so we just have to simplify. So we go ahead and plug it in. So we have 5 minus 2 times 11 over 7. We go ahead and multiply this. 2 times 11 over 7 gives me 22 over 7. 5 minus 22 over 7 gives me 13 over 7. So that's my x value. So my solution would then be 13 over 7, comma 11 over 7. It's an ugly solution, but it should be correct because we can easily just plug these numbers back in. Again, horrible way to check, I understand. Plug it in and make sure they come out true for both. If you want, you could also graph these equations and check your solution that way by finding the intersection that we talked about in class and work it out that way. Okay? But if you're going to do it that way, you'll probably have to change these fractions into decimals to see what they look like, because the calculator will only give you decimals for the intersection. Okay? Alright, let's go ahead and try another example. So let's try this one. Y equals x minus 6 and x minus y equals 6. Okay? This one's really nice because, again, it already has a variable solved for itself. So we're going to take what y equals, the x minus 6, and plug it into this y in the other equation. and simplify it. So now we have x minus the y, which is x minus 6, equals 6. So we go ahead and distribute out this negative sign, because that's really a negative 1 now. So we get x minus x equals, or plus 6 equals 6. Well, x minus x is 0, so I end up getting 6 equals 6. Now, when I don't have a variable, but I get a true statement, that tells me something about my answer. It doesn't matter what I put in there, I'll always have a true statement, so I can put anything in there, and it would come out true. So I would have infinite solutions here. So you can, and again, you can check your answer by graphing it. When you graph it, you'll notice that the two lines are actually going to be overlapping. Okay? This is a consistent dependent system. Alright, let's try another example. Again, if I'm going really fast, just pause the video so you can catch up, okay? I'm trying to make it a short video tonight. Find the solution to this system. We have y equals negative 4x plus 5. We have y equals negative 4x minus 9. You might be able to tell what the answer is just by looking at this problem, okay? But if you haven't noticed it, I'm not going to tell you until the very end, okay? So, again, these are both already solved for y. So I can take either of these. I can take this first one. Sorry, I got a meeting now. I can take this first one and plug it in for the y here, or I can take this y and plug it in for this y. So I'm going to take this bottom one, negative 4x minus 9, and plug it in for this y. So I get that. And I'm going to go ahead and solve. So I add 4x to both sides. I end up getting negative 9 equals 5, which is not true. So when I get rid of all my variables and I get a false statement, that means no matter what I put in for x, I will never get a true statement, so there's nothing that works. So my answer is no solutions. Now, here's the shortcut part. If you looked at these two, they have the same slope. What do you know about lines that have the same slope? They're parallel. So if they're parallel, you think about the graphs, they won't intersect at all. So that means there's no solution. This is an example of an inconsistent system. Okay? The last thing we're going to do is you have to try on your own to solve the systems using substitution. I want you to practice substitution. You are more than welcome to check your answer using graphing calculator, but I want you to solve by substitution. Okay? So pause the video. When you come back, I'll have the answers for you. Okay. So here's what you should have gotten for the first one. You should have gotten 1 comma negative 6. And for the second one, you should have gotten negative 6 comma negative 6. Okay? These came out really nicely. Alright? Now, if you have any questions on this, please write it down on the side of your notes. I'll be happy to answer them next class. Other than that, I will see you next time. And I'm not going to say bye, because I'm going to have to get out of this thing first. There we go. And now I will say goodbye to you. Bye-bye!